Hello class, this is section 4.5, solving exponential equations. So the first one says 5 to the 2x minus 1 equals 1. Well, whenever you have equal to 1, we know that the exponent has to be 0 because of this property. Any base to the 0 power is 1. Therefore, the exponent must equal 0. So we can write an equation that says that 2x minus 1 is equal to 0. And if we solve, we will get x equals 1/2. Okay, this next problem. So they want two solutions. They want the exact solution, and they want the calculator approximation to 6 decimal places. So let's start with the exact solution. First thing you always want to do is clear out the coefficient, which is 3 in this case. So 3e to the x equals 13. The way we clear that out is by division. And now we have e to the x is equal to 13 thirds. And now in order to get rid of the e, we want to do the inverse of e, which is natural log. So we can do the natural log to both sides. And what happens here is the exponent will come down because of the property that one of the properties of logarithms. So we're going to have x natural log of e equals natural log of 13 over 3. And then the natural log of e, that's just 1 because these are inverses of one another. So these essentially just disappear. They become 1, and 1 times x is x. And on the left side, this is our final answer. That's the exact solution. Now, to use the calculator, we can just type that in the way you see it. So natural log of 13 divided by 3, close parentheses, is getting 1.4663, 1, 2, 3, 4. I need 2 more decimals. 37 is what I'm getting. All right, for this equation, notice it's in the form of a trinomial. So you can pretty much treat this as a trinomial. We can even do a substitution. I'll do what I call a y substitution. So you always want the y to be the middle variable without the coefficient. So that's going to be e to the x. So that when you square this side and both sides of the equation, you get y squared is equal to e to the 2x, which is exactly what you need over here. So rewriting this equation using the substitution gives us y squared minus 5y plus 4 equals 0. And this should be a pretty simple trinomial to factor. You should get y minus 4 minus 1. And the two solutions, if you set these equal to 0 and solve, will be positive 4 and positive 1. However, we're not done. We need to resubstitute the original substitution for y and solve these two equations because we want to solve for x, not for y. So if we do that, this becomes e to the x equals 4, and this one becomes e to the x equals 1. So now we have these two equations where we need to solve for x, and the way we do that is by taking the natural log of both sides in order to clear out the e. So let's do that now. Natural log of both sides. And then we can go ahead and move these exponents to the front again. So now we have x natural log of e equals natural log of 4. Here we have x natural log of e equals natural log of 1. And remember what happens here. This becomes 1. And so now we simply have x equals natural log of 4 and x equals natural log of 1. Well, the natural log of 1, let's see what that is. Should be 0. It is 0. All right, so the smaller value would be, they do want us to round to 4 decimal places, so let's calculate what this one would be. Natural log of 4 is going to be 1.3863 if I round. So the smaller value would be 0, and the larger value would be 1.3863. All right, solve the logarithmic equation for x. Well, remember, when there's no base, that means that it is base 10. So I'm going to write that in. And then I'm going to go ahead and convert this to exponential form by switching these two terms. So the base is 10, the exponent is 2, and that equals to 4x plus 7. So this becomes 100 equals 4x plus 7, and we have a pretty simple linear equation to solve. I'm getting 93 over 4, which would be our final answer. This next one, we do want to use the law of logarithms that allows us to combine two logarithms into one. And in this case, since there's an addition sign here, that means we're going to multiply a times b. All right, so when we multiply those two, you're going to have to expand that out. Let's expand that out now. Well, if you multiply that out, you're going to get x squared minus x minus 6. So this equation becomes log base 14 of exactly that, x squared minus x minus 6. And that, once again, is because we multiplied this times this because of the addition sign, which means that we were able to use this law of logarithms. And that is equal to 1. So now we can convert this into exponential form by crossing out the word log, swapping these two, and the base is 14, the exponent is 1, and that's equal to x squared minus x minus 6. All right, we can subtract 14 to both sides to make that equation equal to 0. And now we have x squared minus x minus 20. And we have a trinomial that we can factor, which becomes negative 5 and positive 4, which means that the two solutions are positive 5 and negative 4. However, you must check your answers to make sure that they actually check out, because there's one thing that you can't do, and that is you cannot take the log of a negative number. So whenever you have log of x, for example, the domain must be greater than 0. So you can't even have a 0 in here. So 3 would not work because 3 minus 3 is 0, and you can't take the log of 0. You get undefined. It's not defined. It's not part of the domain. So you just want to make sure that these two values do not give you a non-negative answer. All right, so let's see. If you plug in 5, you're going to get 5 take away 3 is 2. That's fine. 5 plus 2 is 7. That's fine. So this one is a good solution. And if you plug in negative 4 minus 3 is negative 7. And you cannot take the log of a negative number. Same thing. So this will not check out, but this one will. So your only answer is 5. Last problem, I think, is this investment problem that says a man invests $3,000 into an account that pays 7.5 interest per year, compounded quarterly. There's our keyword, quarterly. Tells us that n is equal to 4. Our interest rate is 0.075. And our principal amount, $3,000. And our t is 3. So if you recall, the formula for investments or interest is as follows. Plugging in these numbers gives us 3,000, 1 plus 0.075 over 4, 4 times 3. Okay, and let's see, find the amount after 3 years. So if we type that into our calculator, should get getting 3749.15 if I round to the nearest cent. How long will it take for the investment to triple? All right, in order for the investment to triple, that means it has to go from 3,000 to times 3. That's 9,000. So in other words, A has to be 9,000. So 9,000 equals the principal, 3,000, and everything else stays the same except for the time. We don't know what time is this time, so t is our variable. So we still have compounded quarterly, so 4 times t. So what we're solving for is t this time because we're looking for how long it will take in days. In days. So, in years. So let's see when this would be. So first thing you want to do is clear this out by dividing both sides of the equation by 3,000. So you end up with 3 equals 1 plus 0.075 divided by 4 to the 4t. And now what you want to do is you want to take the log of both sides. You can do a natural log if you prefer, or a normal base 10 log. The point is you want to get the exponent to come down because you got the variable there. So I'm going to do base 10. So if I do base 10, that means it's going to be a log, all right, of both sides. And remember what we can do to the exponent, move that to the front. So now we have log of 3 equals 4t log of 1 plus 0.075 over 4. And then the final step would be to divide both sides by 4 log 1 plus 0.075 over 4. Because you want to get t by itself. There you go. All right, so that's what we're going to type into our calculators. Just be careful. You might want to put parentheses here as well to make sure that the 4 and the log are both in the denominator. So t should equal to log 3 divided by parentheses 4 times log 1 plus 0.075 divided by 4, close parentheses, enter. Getting 14.78. It says round your answer to 2 decimal places, so I'm getting 14.79 if I round up. That's how many years it would take for the investment to triple. Oh, there's actually one more problem. So this time, this one says there's a 15-gram sample of radioactive iodine which decays in such a way that the mass remaining after t days is given by this function. M of t is measured in grams. After how many days, that means we're solving for t, is there only 1 gram remaining? So this indicates that that's how much we want m of t to be. So that means that's what we're going to set the function equal to, 1 gram. So the equation becomes 1 gram equals 15 e to the negative 0.081 t. So to solve for t, we have to get rid of the coefficient by dividing by 15 first. Now we have 1/15 is equal to e to the negative 0.081 t. And in order to clear out the e and to bring this down to the front, you need to take the natural log of both sides. And that will allow us to move that exponent to the front. All right, so we have natural log of 1/15 equals negative 0.081 t ln of e, but the ln of e becomes 1, and so that pretty much just disappears. And now we can solve by dividing both sides by this coefficient. So t will equal whatever that is, so that's natural log of 1/15 divided by negative 0.081, which is 33 they want us to round to the nearest whole number. 33.4 would be 33 days. All right, and that concludes this section.